Today, I'm going to show you an experiment using Proteus, the forward bias characteristics of SCR. So from here to the first quadrant, I'm not going to conduct experiment to show the reverse bias characteristics, only the forward bias characteristics I am showing. This video will be very helpful for the beginners. So let us start the experiment. In this characteristics, from 0 volts to till the breakover voltage, a very small leakage current flows. This current is called as forward leakage current, and this mode is called as forward blocking mode. Up to breakover voltage, the SCR will be in a off condition, and after breakover voltage, the SCR turns on, and the current through the SCR rises immediately, sharply, and the voltage drop across the SCR falls to 0.5 to 0.7 volts. So the voltage is very less here once it is turned on. Till the transistor SCR turns on, the voltage increases. After the breakover voltages, immediately the voltage falls to 0.5 to 0.7 volts and the current increases. Let us go to the Proteus now. Open the Proteus software. I have already constructed this experiment circuit, and I'll show you how to construct also. Let us first find out the readings, and we will plot the graph using Excel sheet. Then I'll show you how to construct. Initially, what you should do, first you should know how much is the gate current required to fire the SCR. So how we will come to know? So you should go to the device mode, component mode, and in pick device, you just type SCR. So I have selected the first SCR, S6055R, and here it will be given the gate triggering current is 40 milliamps. So if you choose any of the SCR here, the gate triggering current will be given here. So it is written 40 milliamps. So from this, we will come to know the 40 milliamps gate current is required. So what we should do initially, if I keep the 40 milliamps directly initially only, so I'll not get the characteristics curve like this. I'll not get this type of characteristics because if you keep the maximum gate current, that is 40 milliamps, immediately as soon as the power supply is turned on, SCR is triggered, and you will not get the breakover voltage, and these characteristics you will not get. So what you should do, first you should keep the power supply voltage to some value. The maximum value I have taken 45 volts, and the gate current to the lower value. Then you turn on the simulation. So once the simulation is on, so it is showing 11.9 milliamps. So if the SCR is not on, whatever the input voltage you are applying from the power supply, the same voltage appears between anode and cathode. This is anode and this is cathode. So if the same voltage is appearing between anode and cathode, then it means the SCR is not on. If the SCR is on, the voltage between anode and cathode will drop to 0.5 to 0.7 volts. So how to do this? You just keep on increase the gate voltage, because if I give 40 milliamps directly, and SCR will be immediately turned on, I will not get the sufficient readings. So I'll find out the gate current at which the SCR is fired. So now I'll keep on increase. I increase to 12.0 milliamps. The SCR is not fired, and it is 45 volts only. Again, I'll increase 12.1. So like this, I'll keep on increasing now. You just note down 12.4, 12.6, 12.7, 12.9. SCR is not fired because 45 is remaining. I am keep on increasing this. Yeah, that 14 milliamps SCR is not fired. 15 milliamps not fired. 16 milliamps, it is not fired. So keep on increase this voltage, gate current. So 19.5, 20 not fired. 21 no. 22 no. 23 no. Now you do it sharply because I have already done it. It will fire at 23.5. Be careful now. 23.4. See, from at 23.4, the SCR is fired and the applied input voltage is 45 and the voltage drop between anode and cathode is 0.59. And here the maximum anode current is flowing. Now from this you will come to know that and for S6055R, the gate triggering current required for this SCR is 23.4 milliamps. So after this, again, you reduce the power supply voltage. Now you start taking the readings. I'll stop the simulation and here go to the edit properties. Initially you keep 5 volts. Here I changed the resistance value to 330 ohm in order to get good readings. And here gate voltage applied is 23.3 using this pot. Now I applied 5 volts and I am getting voltage between anode and cathode is 4.323 and current is 2.34. So I'll note down here. This is VAK in volts. This is RPS voltage. RPS voltage. Here I'll write VAK voltage, that is voltage between anode and cathode, and this is current IA. Okay, for 0 volts, current is also 0, and for 5 volts, the voltage is 4.23 and current is 2.34. Okay, so in this way, we will note down some currents. Next, I'll adjust this to 10 volts. So directly you can't adjust, you stop the simulation. Go to edit properties, adjust to 10 volts. Then click OK. So I'll note down the voltage. For 10 volts, it is 8.88 and current is 3.39. Next, I'll adjust to 15 volts, stop the simulation, edit properties, 15 volts, click OK, start the simulation, 14.2, 14.2, current is 2.34. This is very small current. This is a leakage current in forward blocking mode. Increase to 20 volts. Run the simulation. So it is 19.2. Current voltage is 19.2. Current is 2.3 only. 2.34. Here also it is 2.34. Now I'll adjust to 25 volts. After 25, we increase in small steps, not in steps of 5, because your SCR will fire. 24.2 and current is 2.34 only. Now I'll not go to 30 because SCR will fire now. It will start conduct. So I'll make it to 25 to 26 only. Click OK. So I got 25.2. and current is still 2.34. This is leakage current. Stop the simulation. Now I'll increase in steps of 0.1, 26.1. Lastly, we will do it 25.3. And current is 2.34 only. Now 26.2. Run the simulation. 25.4. Just observe the readings, how I am getting. Now voltage is 25.4. Now I'll make it to 26.3. 26.3. So it is still not fired, not become on. 25.5. Current is 2.34 only. Stop the simulation. 26.4. 26.4. So it is 25.3. Current is 3.39. 25.3. See, observe the reading. The voltage is reduced. Current is increased 3.39. In next step, it will fire. When SCR turns on, the voltage immediately drops to 0.59 or up to 0.7. You just note down, and the current becomes very high. 26.5 I will make now. This is very careful reading. Be careful. Now I'll turn on. See, SCR is fired. The voltage is dropped to 0.6 for 26.5. For 26.5, the voltage is dropped to 0.6 and current is immediately increased to 78.4. 78.4. So next, no need to take in steps of 5.1. I'll directly increase this to 30 volts. Press OK. So the SCR current is very, very high. The voltage is remained at 0.6 only. And the SCR current is, anode current is 89.0. Now I'll make this to 35 volts. 35 volts. 2 more readings we'll take and turn on the simulation. Current is very, very high. Voltage is remaining at 0.61 because it is on. Current is 104 milliamps. And last reading I'll take. If you want, you can take or you can stop it. 40 volts. 40 volts. Click OK. Run the simulation. Current is still high, 0.61, and current voltage is 6.61. Current is 119. I'll stop taking the readings. So these are in this way. By keeping the gate current properly, you will get plenty of readings. If you keep the gate current at higher end, we will not get sufficient readings. So our curve will not look like nicely, it will not get. So now I'll show how to draw the graph. So this is my Excel. Okay. So go to insert. Click on scatter chart. Choose this. Sorry, I have to select the readings. I have to select only VAK and IA. And go to insert because the plot is between voltage versus current. Exactly, I got this. So on x-axis, I am taking VAK, go to layout, title axis, horizontal axis. So current voltage is VAK, and on y-axis, go to the axis title, vertical axis. On y-axis, the current is IA. So it is IA versus VAK versus IA. And title, we can give it as SCR Characteristics, forward bias characteristics. Okay. So this is the graph, very nice graph we get from 0 to the breakover voltage is, here the breakover voltage is 26.5 volts. At 26.5 volts, SCR is fired. This 26.5 is called as the breakover voltage. I'll mark this with yellow. So the breakover voltage is 26.5. After breakover voltage, the voltage is immediately fall to 0.6. And the breakover voltage is 26.4. So the 26.4, the SCR started conducting. SCR started conducting, and after 26.5, the current is increased to a very high value, 78.4. So this is the, here it is in fully conduction mode, and this is in a forward blocking mode. Let me draw the circuit. How to draw this circuit, I'll show you now. So this is my Proteus circuit diagram. The same circuit diagram, how to show, I'll draw it now. Stop the simulation. Close the project. Select the new project. Give the name of the project as SCR Characteristics. Go to next. I'll give the project name SCR. SCR Characteristics. Click next. Next, next, next. Finish. So go to the component mode and pick SCR. I am choosing the first one only. You can choose any of the SCR, and please check the IGT current and place here. So I want gate this side. You do X mirror. Then I need 1 kilo ohm resistor. Type is RES. So you will get generic symbol. Place here. And select this value as 1 kilo ohm. Click OK. And you need one DC multimeter to measure the anode current. DC ammeter, and place here. This is in milliamps. Click OK. Then you need one battery. Type battery here. Okay. So I am taking battery active DC source. Click OK. Or you can take V source also. Or you can take battery also. I'll take V source. V source or battery, anything you can do. Connect here. And you need to measure a voltage. So I need one more voltmeter. DC voltmeter, and place here. And you will need one more voltmeter to measure the voltage between anode and cathode. Okay. Then you join all these things. Join voltmeter here. This is VBE. This is to just check the power supply voltage. And towards the gate side, you need one more resistor. Connect this to gate resistor. And set this to 1 kilo ohm. Click OK. Then one DC ammeter. Then you need one, in order to vary the gate current, I need one pot. I select pot HZ. I'll take pot HZ. Click OK. And I'll place here. The value of this, I'll select 1 kilo ohm. It is already 1 kilo ohm. Next, I need one battery. I'll connect here battery. And from here to here. And here to the ammeter. And from here to battery. Okay. So this battery I'm going to set for 24 volts because my SCR will fire after 23.4 volts. So I'll set this to 24 volts. And the wiper you can connect to the same line. And you okay, this much is enough. Now we need one ground. Connect to the ground. Okay. So this is about the construction of circuit.